mute, and also ensuring that we respect each other. Respect each other, and knowing that if you need to ask a question or say something, make a comment, that we raise our hands, that we raise our hands, and we then ask the question in that regard. So yes, that we do that, and I know that we are all adults in here, and that we would be doing that, ensuring as I ask that all our mics are on mute, and then everything should go well. Right. Okay. There's no one that has any questions that they want to ask me, anything like that, so we will continue. This morning I'm looking there, I see someone has typed something in the chat box there. You are not included, Noloiso, but I've included everybody in the QQS450 class. Do you receive the emails when I send to QQS450?
Yes, sir, I do.
You do receive it? So then,
I don't.
So then you should be receiving, because all the recordings and everything that I have on MS Teams, I include every time I say in there. I need to make a note of that. Every time I state in there that it must be sent to QQS450, and if there's an additional name, then it would add that automatically, or it would tell me that there are that everybody is included in there. But I will most certainly do so again, and your student number is 21634239. I will check on that after the class again. Okay? I will do that. Because you should be able to have the schedule, everything that should be on MS Teams, you should have access to. Or do you have access to anything on MS Teams? No, Luiso? Do you have access to anything on MS Teams?
No, Luiso.
Maybe there's a connectivity issue. Only last week. Okay, I will ensure. I will include you in everything. I will include that. Go back to the front, and I will include that everything. Okay, right. I see your hand has been raised there, Sandile.
Good morning, sir.
Morning.
Yes, I just want to raise a similar concern to that one that you just dealt with. I think I have a similar problem with that lady who just raised concern now, because I do, I actually do have access to the MS Team, but I can't access the materials. So I don't know whether it's me who has a problem in terms of using the platform, but I've tried. But I can't access the material, because when I go to the files, I find nothing.
You go where it says class material.
I can't find any material.
I will. Let me just have a look there quickly. Just to see something quickly. Can you guys see my screen there?
Yes, I can see your screen.
Can you see my can you see my screen? No.
I can see your screen, sir.
And you can see where I went in. You can see all the stuff that is.
Yes, I want to. The thing is, when you go to the teams, the option for teams, QS does not show on those modules that are there. I don't see any QS.
You see
QS
nothing?
is only on the chart. I only find it on the chart. I only find it on the chart, not on the Teams.
You mean that you don't see this? You don't see this? You don't see that?
You see the second option below there.
Did you see what I've circled there? Did you see that?
Yeah, I can see that.
On your side, do you see that on your side?
No, I don't have that on that option. I have QS on the chart. I can only access QS on the chart, not on Teams. Not
in the chat, not on Teams.
Yes.
Then it must be where you're going through, because if you have a look at that, that is where we should be going in, and that is where you should form part of the team, and you should see that, and then in that you should then also see, and when you are in that, you should then also see class materials. And once you go into class materials, you should have access to everything there that you can see there. You should have access to all of those files in there.
Yeah, so that's it. That's what I was thinking, is that maybe you just sent me an invitation without saving me on the thing, because I don't know.
But you see, with me including you on the invitation, it also gives you the automatic access into Teams. That's what it does.
Maybe it's me who has a problem with the platform, because yes, on the Teams I can only access it on the charts.
But what I'll do, I'll therefore have a look at it outside of this, and we would after the class, and I'll have a look to see where we can ensure that we can include you in that.
Okay, no problem. Thanks.
Okay, so we'll do that.
Yes. Thanks.
Okay, right. So last we worked together, we worked with the powers, and then we said we would now start working and looking at the inclusion of the power caps. And when I now go and I upload the power caps, when I upload the power caps, I then go. Can you guys cannot see my screen, can you?
Not yet, sir.
You cannot see my screen. Okay. I will upload. Can you see my screen now? Right, you can see my screen. And I'm trying out a new toy to ensure that I can do what I need to do. Okay, so we now said that we need to draw, and we need to now measure the power caps. And when we look at the drawing of the power caps, I'll get into another drawing quickly on the power cap. No, it's not that one. No, I need to get into another one. No, I can. Let me work with. Let me look at that one. Okay. When looking at this drawing, and if you have a look at, I actually need to take that out and go out of this and share the other one. This is what New Toys does. It messes with you so that you cannot do that. And now I will. Can you guys see my screen?
Yes, so we can see it.
What do you see on my screen that?
I can see that you're on Teams and you
can see all those other aspects there. Okay.
Yes, sir.
Right, but that is not what I want for you to see. I need for you. Okay, I will have to work with what I have here because I cannot flip this drawing around. Okay, you can still see my screen. You can see this drawing. Can you see that? It shows type B.
Yes, I can see the drawing.
Okay.
But then, could you please rotate it?
That's what I'm trying to do. I'm trying to rotate that one, but I will have to quickly go into my Teams to do something else so that I can have it. I cannot rotate that now, but if I do, okay, I will bring in a drawing that I can, in fact, that I do have rotated. Why would it not do that? Anyway, I will upload what I have on my second screen because this is what I wanted to show. Can you see my screen with that drawing now?
Yes, so we can see it.
You can see it now. Now that's the one that shows that it is. That shows the drawing. It shows what we need to do. And what I'd like to point out here is the fact that we now need to work on these pile caps. And you can see the top of these pile caps, they are the same. The tops of these pile caps are the same, and they both reflect that they are at 28194. But I need to excavate for them, and I need to go down. If we have a look at the depth we need to go down, we'd have to go down from there, to the bottom of my pile, of my blinding that I need to excavate to. So in excavating to that level there, it means that I now need to do certain things. We already stripped back our pile caps. So I now need to go, and I need to go to the bottom of that level of 27027 on the one side for the type A pile, and to the level of 27104 on type B pile. So when we're dealing with that, when we're now going to go and we're going to look into it and bring out our excavations that we have, that will then bring to us the section that we now have to go into doing our excavation, ensuring that everything that we have in there is. You are still only seeing my drawing, right?
Yes, sir.
Okay, you're still only seeing my drawing. Right, and as you can see in that, what we now have to go down to is the following. We now have to ensure that as we get there, we will have to measure down to that and down to that level there. Can you now see the writing that I've done on the drawing there? Is there any writing that had appeared there with the pen?
Yes, sir. I can see the orange line from the ground level to the blinding.
Okay, so you can see that, but you cannot see anything other than that. Okay, but now when we're dealing with that, when we're having to work down and excavate down, we now need to determine what that depth is, and we will have to then say that it is the 28500 minus the 27027. That gives me a depth of 1396 that we now need to excavate down to. That is for type B, and we have 1473 that we need to excavate down to for type A. And we will do that and show that in our, as I just flip over into my dimensions, to say we need to go from there to the bottom there, and from there to the bottom there. And we'll say that minus that, and we'll also indicate by showing that it is that minus that. And our depth that we would have there for type A would be 1 QQS4000, and for type B, we would have 1. Oh, try and make a 3 with a mouse. 1, 3, 9, 6. So that would be our excavation depth that we would have on the floor for the two types. And obviously we know how many we would have, and then when we go out, I'm going to take that out and I would upload my Excel spreadsheet. I need to take that out and you can see my spreadsheet. You guys can see my Excel spreadsheet?
Yes, sir, we can see it.
Okay, you can see my Excel spreadsheet. So that is where, as you see, we excavate in earth for pile caps not exceeding 2 meters deep below ground level. It's important that we indicate that it's below ground level, and then extra over for excavation in soft rock, 10% thereof, and ditto part for excavating in hard rock, 5% of whatever the excavated volume is. We need to allow for that. So, and all of that needs to be carted away. So it is extra over excavation for carting away surplus excavated material to a dumping site, plus minus whatever the distance is away, or whether the contractor will select that. It does not matter. It does not matter which one it is that we do. Our dimensions that we would have here is, and that we would find from my drawings, which I would then go back to then be from my drawing as I go back to my as I go back to my drawing, my dimensions would then be 3505 by 915, so it's 3.51 by 0.91, and the depth for my type A is 1.47, and I have 4 of those. But at the same time, as we have a look at those pile caps there, let's have a look at those pile caps, and we also would notice that they now have been reduced we've stripped them all back, as we can see over there. We've stripped them back, so we now also need to deduct that, and that is why, and this is where we're doing this, we're going into the timesing column, and we indicate, we do know that these piles are 480 millimeter in diameter, so we will use half of them. It will be 0.24 by 0.24 by 1.47 that we will be deducting, times pi times 12 of them. Is that correct? Would that be correct that I'm doing? Deducting the excavation to the depth of 1 meter 470. I'm wanting for us to take this in and to have a look at that and what I'm saying. I'm saying that will be 1.47 that we will be deducting. No one wanting to comment anything or ask any questions? Is that correct?
So,
Yes.
I wanted to ask, why did you use the height of 1.47 when the pile cap only starts below that?
Why did I use 1.47? That's a good question. I've been asked. That's why I'm saying these things, so that you can talk to me and tell me what it is that you are thinking at this point. So, what do you think? Is the 1.47 the height there? Is it correct, or what should that height be?
I think so. You must take the level that you've been given from the pile cap, which I can't see that. I think it's 27,421 to 27,027 to get the height that you're supposed to subtract by.
You say I should use 27,427 minus 27,027.
Yes, sir.
So you're saying it should be 0.4 and not 1.47.
Yes, sir.
Well, why do you say that?
Because the pile only starts from that reduced level, which was 27,427.
And that is what we will be deducting, right? Is that what you're saying?
Yes, sir.
Absolutely correct. Absolutely correct. Can we all see that? Can we all see that? It's only one person that can see that. Not everybody can see that. Yeah. So what we deduct there is 0.24 by 0.24 by 0.4 times pi times 12. Because there's 12 of those. And we also add, when looking at the sizes of the pile cap type B that needs to be deducted, we have those sizes as 2.134 by 0.914. So it's 2.13 by 0.91. And the depth that we've indicated there is 1396, but the 1396 is reflected as 1.4 as we write it to 2 decimals only. So that will be by 1.4. And we will be deducting again the pile caps. It will be 0.24 by 0.24 by what's my next dimension now? It is 27,427 minus 27,104. That gives me 323. So it will be 0.24 by 0.24 by 0.32 times pi times 4. Because we have two of those sets of piles as per the information that we were given on the drawing, and that will be then multiplied by another 2. So in total there will be 4 of those piles that we need to deduct. And for these, we also now need to do risk of collapse for these pile caps. We need to do risk of collapse for them. And how will the risk of collapse be? The risk of collapse, if I have a look at my depth that I have that we've ascertained, the 1473 and the 1396, we now have that. We need to do the risk of collapse to those. So my dimensions will be the same. I will not be interested in anything other than the depth that I've excavated. And the depth that I've excavated here would be 13473 and 1396. So my risk of collapse would then be therefore be 3.51 by 1.47 times 2 sides, times 4, because I have 4 of those pile caps. And then 0.91 by 1.47 times 2 times 4. And that is all for my type A pile cap. For my type B pile cap, it will be the 2.13 times 1.4 times 2 times 2, and 0.91 times 1.4 times 2 times 2. So that was for my risk of collapse. All with me? Everybody with me? Right, I see there's a thumbs up. Okay. Okay. We then have one of our favorites would then be my keeping excavations free from water, and that's measured as an item that we need to do. So now I will have to now measure the concrete that goes in there. As I look at that drawing, I can see on that drawing that there is concrete in there. I see that the concrete is separated in 2 sections. One is blinding, and the other one would be my reinforced concrete. So it will be 10 MPa. It will be concrete, 10 MPa concrete, and whatever the size stone is that we will have, whether it be 19 millimeter stone or 13 or 25 millimeter stone, in blinding below my pile caps cast against my excavated surfaces. My dimensions, I can do this in one of 2 ways. I can say 3.51 times 0.91 times 0.1, and I have 4 of those sections of blinding, but I will still have to deduct the piles that I see that protrudes through the section where I'll be casting the blinding, and that will be 0.24 by 0.24 by 0.1 times pi times 12. Because that is the number of piles of type A that will protrude through my blinding. I then also have 2.13 by 0.91 by 0.1, and I then deduct 0.24 by 0.24 by 0.1 times pi times 4, because 4 is the number of piles for type B pile caps. In total, and with that, going with that is, I'll then also have to do my concrete. My 30 MPa 19 millimeter stone reinforced concrete 30 MPa 19 millimeter stone in pile caps, partly cast against our excavated faces. Why partly cast? Because part of that is cast on top of my blinding that you see there. Part of that is cast on my blinding. And therefore, I'll be using the same dimensions that I had for my blinding. So it's 3.51 by 0.91 by 1.07. All right, where do I get this 1.07 from? The 1.07 is given to me as 1067. When I now convert that to meters, and I write it to 2 decimals, it will be 1.07. And there's 4 of those piles. But I also have to deduct. I have to deduct for this section here where that goes into where the pile goes into my reinforced concrete. That will be 0.24 by 0.24, and I need to determine what that height is. And that height is given to me when I have a look at that and I look at the levels. The levels would then be 27203 minus the top of my blinding or the bottom of my pile cap, 27127, and that gives me 76 millimeters. Give me 76 millimeters. So I will then multiply that by 0.08, what needs to be deducted. That height there is 0.08, and that is times pi times 12 of them. The same token, I need to calculate the reinforced concrete in the type B pile. And I see that the dimension given to me over there is 990 millimeters or 0.99. So my dimensions there would be 2.13 by 0.91 by 0.99, and I have two type B pile caps. So my quantity of which I will have to measure for the concrete is times 2. And they have to deduct what the protrusion of the pile through into my pile cap. It will be 0.24 by 0.24 by 0.08 as it comes down to the same height that it protrudes through into my pile cap, and times pi times 4 of them. Now, we said that when measuring formwork, we get different types of formwork that we could measure. But when I look at this drawing here, if I can just clear some things on this drawing, what I need to reflect here. Generally, when my pile caps would show, they would then reflect and they would show they will be exposed to the outside, because the pile caps, we said, piles and pile caps are normally fitted or designed to go in areas where the footing or the founding material will not be that strong and firm. So it means that this concrete would be exposed, in most instances would be exposed to for the duration of the time that the structure would be standing there. So in most instances, we would go and we would measure for smooth formwork to the sides of the pile caps. Because the reason for that is that it would then be placed, it'd be exposed, my apologies, and you would want for that finish to be a pleasing or aesthetically pleasing one. So when we measure our smooth formwork, to measure smooth formwork to the sides of our pile caps, it will be measured in meters squared. And in measuring that, we'd also look at back excavation of the vertical sides of the excavation in earth for working space exceeding 500 and not exceeding 1 meter 500 deep, for placing and removing the formwork to the sides of the pile caps flush against the excavated face. What does that mean? It means the following. It means that when we're looking at this from the top, that would have ground up against it. But we need to ensure that the formwork can get in there, that the support work goes in there, and we need to allow for working space in order for us to get that formwork placed in there. And that formwork would be going in at the bottom here, to be going down here. Now that is upside down again. I don't know why I copied it in like that. But that formwork needs to go in on the side. Then we need to create working space for that. And when measuring working space, we know that working space is measured in meters squared. When they measured in meters squared, we know that it's measured, and the standard system tells us that it goes in exceeding 500, not exceeding 1 meter 500, exceeding 1 meter 500, not exceeding 3 meters, and that is how we measure for our working space. We also have to measure extra over back excavation for working space for excavation in soft rock. Why are we doing that? Because our instructions say that everything that we do, we need to allow for 10% of whatever it is that we're doing when it deals with excavation, that we have to allow 10% for excavating in soft rock and 5% for excavating in hard rock. So even when we're dealing with working space, what is working space? What does it mean? Working space means that we are now, that the contractor is allowing for his or her workforce to be able to safely work in that area, and we need to ensure that it is allowed for. And now we know that 5% of the soil would be hard rock, and 5% of that would be 10% of that would be in soft rock. So we include that when we say extra over back excavation for working space for excavation in soft rock. We say times 10%, and ditto, but in hard rock. Now let us have a look at our dimensions. Our dimensions tell them that it would be, flip again. Our dimensions tells me that we need to measure for formwork for the 1067 and for the 990 over there. So it'll be 3.51 times 1.07 times 2 times 4 and 1.91 times 1.07 times 2 times 4 for type A. And for type B, we're looking at 2.13 times 0.99 times 2 times 2 and 0.91 times 0.99 times 2 times 2. And that, ladies and gentlemen, brings us to the measuring, to the end of my dimensions for the measuring of the piles together with the as the pile caps for drawing RC010. I'll now allow a couple of moments for us to ask questions and move through like that. Any questions? I don't see any hands. Are we all good? Also don't see any thumbs ups going through there. So are we all good with what it is that we've seen? Can I say learned this morning too? Insofar as the measuring of the power caps are, different power caps, and how we go about dealing with them. All happy? We have a question. You have a hand. Tutuzela?
Morning, sir.
Morning.
So, I don't think that I'm happy with the depth of the excavate.
You don't think you're happy with the depth of the excavation? The depth from there. Oh, you cannot see my screen. Okay, let me just upload it again. So you don't think you're happy with the depth of the excavation from there, from that to that level?
Yes, because I think according to your specification on the drawing 010, the bottom level of the excavation should be 27203 for type A, before the allowance of the landing layer that is 100 millimeter.
But you see the 27203 is the top of my pile. And that is inside my pile cap. I cannot excavate to there. I have to excavate into the bottom of my blinding in order for me to ensure that everything gets in there. And that pile cap, that pile needs to sit part into the pile cap. Can you see on my drawing?
Yes, sir, you can see it.
Now, what is the issue with the depth of the excavation? Because we have to excavate to the bottom of this blinding.
Yes. So, sir, before that 100 millimeter blinding layer, so what is that? How do you think that depth? That is 27. I don't see these numbers.
Can you not see my screen?
Yes.
Can you
I don't see them well.
You see the level there is 28,500. That's a reduced ground level.
Yes.
Okay? Can you see this 27,027? That is in yellow.
Yes, and then how did you get that one?
I said 28,500 minus 27,027. You punch in your calculator, punch in 28,500 minus 27,027. What do you get? 1473.
Yes, sir.
Now that is the excavation depth. Because we cannot fit the blinding if we've not excavated to below the level of the blinding.
Yes, I can see that. But I think I need to know, how did we get that 27027?
That level is given to us. It's on the drawing. The level is given to us at 27027.
27027.
Yeah.
Is it on the specification, sir?
It's on this drawing that I've also uploaded. The one that you see here, I've also uploaded this onto the MS Teams.
Okay, I think I'll go back and check.
I can also, let me just, if you have a look at what the drawing says, this is what we did. The piles we cast to the level 27427 and later stripped back. We're given that 28,500, which is ground level. It says that the piles are 600 millimeters from reduced ground level to the bottom toe.
Yes, okay.
Right? So, and then, but we were also given, and here we say that the piles, that giving the level at the top of the piles for type A, and we are given those levels. That is for the piles only. Then the next drawing that we have, which I have also uploaded, is this one that shows where these levels come in. The details of all of those it shows on there where we get those respective levels from.
All right. No, I can see. I thought that this one was just showing how these levels that are specified on the specification.
No. The levels this drawing was also given as part of the upload.
Okay. No. I can see it now.
Okay.
Thanks,
so you have that now.
Yes, I will have them.
Okay. So you'll be able to work from those.
Yes, I will be able, because if I have seen, it's just that I thought you were analyzing how these things to be read from the specification, not knowing that those were not appearing on the specification. Then I could find out on this particular drawing.
Yeah, I do understand that.
Okay.
Okay.
Thank you very much.
Okay, you're welcome. Are there any other questions? Mr. Mutlele?
Hello, sir.
You.
My question is there where we excavate for the piles.
Yes.
The part where we deduct the actual protrusion of the piles for pile type B.
Come again, Mr. Mutlele. I did not get that.
You see where we excavate for the pile caps.
Yes.
There's the part where we deduct the protrusions for the pile for the actual piles.
Yeah.
There where we deduct the type B piles. I just want to understand the depth there because I see it says I'm getting a different depth.
You're getting a different depth.
Yes.
What's that? 27.
You see, we deduct. We say 4 multiplied by pi times 0.24 times 0.24 times 1.40.
Oh, that must be 176, no? Did you get one? Because we remember we've stripped these power caps back already. The powers we stripped back to 27280. Should be 27280 minus 27104.
Okay.
So instead of 323, it must be 176. Now I made a mistake there with that calculation there. Please don't shoot me, but that is. So what we go back, that would be 0.18.
0.18. Okay, thank you, sir.
Thank you so much, Mr. Mutlele.
All right.
You know, sometimes even the great make mistakes, and we appreciate the assistance that we also get from you guys. Yeah. Okay. Any other questions or comments or observations? Right. Okay. If there aren't any, we would now make a shift. We would make a shift over, and we would start out. I'm just going to have just going to allow for us to have a 5 minute bathroom break, and then we would start out with the next section, and that would take us into composite slabs. And if you go into your MS Teams, you'd notice that we have uploaded. I've uploaded there's RC 0016218. It would be a range of it is a range of drawings and workings out that I would just show you quickly where you can see that. You'll find that in files, in class materials, you'll see the first one right at the top there that says Composite Slabs RC 016, 017, and 018. You can go in there, if you open and go in and see what reflects on there, you'll see that there are hollow blocks, a drawing that shows ribbon block slabs with the workings, also shows trough slabs with the workings, as well as hollow blocks, coffer slabs with its workings. So just take a 5 minute break, a bathroom break. whilst you get that out, and we will be working with those in 2 minutes. Okay, I'll be back in 5. Okay, right, guys, I'm back. Before we start out with this, I'd like to know, and just like to check on this here. Do you guys have, when you access YouTube videos from a link, do you use a lot less data than this live streaming? I wouldn't have a clue, but I'm asking because I'm trying to venture into doing something like that. Do you guys know how much you don't use lots of data when you do YouTube streaming and that, do you? The speaker, I see your mic is on. Do you have an answer for us on that? Chipokushle? Or is that just your mic that's on? Okay, because I'm looking at venturing into doing videos where you can see me, where you can see where I work through it all, and uploading them. I'm uploading the links for you to watch doing YouTube. But I don't have much hope for myself with that. But it's something I'm going to try. I'm sure that I can. That I'm not too stupid as far as that is concerned, and I will try with the needed assistance. I will try and do that. Okay. Now we've now done piles and the pile caps and the like, and now I'd like for us to have a look at composite slabs. But before I want to look at composite slabs, I think it's important that we look at what the standard system says. Now, you guys know concrete. You've been dealing with concrete in your third year, and you guys know the various aspects when it comes to concrete. You guys are aware of how concrete is measured, how it's measured in the different spaces, of how it is measured and when I go out and when I try and upload the standard system here by going out.
Mm-hmm.
I upload the standard system, and I'm sure you can see. And upload the standard system here, and we go to the section that deals with concrete. Now we all know that we do with composite slabs. You guys have all, and I'm sure of this. You guys have all worked with ribbon block slabs. Some of you might have worked with trough slabs, and some of you might have worked with hollow block slabs. Now you know the reason for us doing that. The reason for us using, can anybody tell me why we use ribbon block slabs and coffered slabs and trough slabs? Anyone want to venture into and try and find a reason for why we're doing that, using those? Anybody? No, I'll say that. If you have a look at the composition of of a hollow block slab, or even a trough slab, or even a coffin slab, you'll notice that there is a lot less concrete being used. And concrete has weight, and concrete is also expensive. So they come in and they bring in hollow block slabs, trough slabs, and ribbon block slabs to reduce the weight of our concrete, as well as to reduce the cost of what that concrete is. For instance, if we have a 300 millimeter thick solid reinforced slab, it will be a lot more expensive. It could be a lot more expensive than having a coffin slab, or even a ribbon block or a trough slab. So we're using that to reduce on some of the cost, and it also helps in some instances. It also excavates or not excavates, or expedites expedite the curing process in that. So when we look at concrete, first off, we know that concrete, it tells us that concrete is measured, the components, surface blindings, surface beds, casting panels, footings, underpinnings, slabs inclusive of beams and inverted beams, isolated beams, lintels, stairs inclusive of landings and beams, walls, columns, hollow block slabs, coffin slabs, and trough slabs. Can you see the lines that I'm drawing on there? Where's my usuals that normally answer?
Yes, sir, we can see the lines.
You can see the lines that we've drawn there. Now, you can see there that they mention these slabs separate to the one that shows slabs inclusive of beams and inverted beams. So when we measure them, we will not include them in the same description as a slab of a concrete structure that we would have done in third year. So we measure them separately. It is measured in meters cubed, and the components of the casting is excavated faces and so on. We'll go through all of those in the same manner. So when we now go through and we look at our respective sections of our concrete, we now know that it is measured in meters cubed. We need to indicate them separately. We need to show that each one on its own, and that the rest of those would also work in the exact same manner that we would for our normal concrete slab. But when we look at the ribbon blocks, we need to measure our ribs separately. We need to measure the blocks separately as well. This is where we come and we see that it shows our hollow blocks, where we have our hollow blocks, we have our prefabricated beams. We see that the hollow blocks are measured in number. The spacing tiles to the soffit of the solid section is measured in meters squared. The fabricated beams are measured in meters. Now I'm going to go into this, and there are different sections that we need to now take note of when we do deal with our ribbon block that we would have, especially as per drawing number 16, which I will be opening. Okay. This will now be drawing number 16. In drawing number 16, we have a look at this. The next couple of drawings, 16, 17, and 18, is just a small scale. If you have a look at the overall dimensions of that, you'll notice that the dimensions Now 3 meters by 2 meters. It is just a schematics to show how we would go about measuring these respective slabs. That's before we go into the next section that will be a little more intricate. So when we go and we have a look at this, the drawing shows us that we have a 3 meter overall. Shows that we have 3 meter overall by 2 meter overall. And what that shows us further is that it shows me that the dimensions and how this is indicated to us. We have 100 millimeter above my block. We have the block of 200 thick. And then we also have the ribs at the bottom there. And the rib widths are 150 millimeter. As part of the prefabricated block beams, it tells us that it has 2 by Y10 rods running parallel with the beam or the rib. My dimensions, as I said, you'd notice my overall dimension thickness of my slab would be 300 millimeter thick. And what else is there that we can see? You can see it shows us over here where the hollow blocks are and where the prefabricated block beams are given to us. This is what I want for us to take note of. Take note that there those are all my beams. And these over here are all my hollow blocks. Right? And what's important, you notice that the beams, they sit over the concrete beams on the end, but the blocks just sit between the concrete beams. Right? And what we have here, it means that the remainder, this here, what would that be? That would be, if I have a look at my other drawing, that would be part of the solid concrete. Can you see all of that? You see all of that? Right? You can see it's part. That will be part of the solid concrete. And how do I know that? I see that over here, because what I've drawn with those diagonal lines, that there where the solid concrete goes. Okay, we got that. So when we measure now, we will now go and we will end up measuring the soffit of the slab through there, and we will have to deduct everything from there to there. Can you see that? And we will use, what will we use? We will use the dimensions of each of the blocks together with dimensions of each of the beams. And as I go through, and I clear that again, I'll need to move up, and there you'll notice that I'm also given the dimensions of my hollow block, the details of my hollow block. That shows the thickness, which becomes very important. It shows the dimensions, the overall dimension of 200. It shows that. It also gives me the 180 versus the 260. There. That's all dimensions that we will be working with in our quest to calculate or to measure the volume of the concrete that needs to go into the slab. Right? I've also been given the dimensions for my ribs, the width for my ribs. And the height is given to me. Where's the height given to me? The height is given over there. The height is given as that 40 mil there, because what would happen here is my beam would sit there with my next block sitting over there. That'll be my beam sitting in there. That is why I say that the depth of the beam would be 40, and the width is given to us as the 150 millimeter. Okay. All happy with what I'm doing so far? All can understand and see a picture of what is going on in there. Before we even start measuring, I'm familiarizing myself with the drawing. Any questions so far? All good. Right. Now when we go and when we measure this, we say that the following in composite hollow block and prefabricated beam floor slab construction. Immediately when we get in there, we're telling the contractor that must price this, that this is going to be composite hollow block and prefabricated beam floor slab construction. We're telling the contractor that this will not be a solid reinforced concrete slab, that he will have to allow and think outside of that. So we say reinforced concrete 30 MPa, 19 millimeters stone in composite hollow block and prefabricated beam slabs, including beams and inverted beams. Okay, so when I look at my drawing, when I go back to my drawing, we will now measure there to there to there and to there, because we are measuring over everything. That is how we were taught. We measure over and then we come back and we do whatever deductions we need to do. Right. So reinforced concrete 30 MPa 90 millimeter stone in composite hollow block and prefabricated beam slabs, including beams and inverted beams. My dimensions there, as I said, is 3 meters overall by 2 meters overall by 300, which is the thickness of my slab. And then for my beams, I measure my beams there as 3 meters by 200 by 200. Where do I get that? I get that over here. My beam detail. If my length is 3 meters across, it tells me there that that is 200 and my width is also 200. Tells me that my width there is 200 and that my height is 200 as well. Top of that, I have my 1 meter 600 multiplied by 200 multiplied by 200, and I have 2 of those, 2 of each, 2 of the 3 meter beams and 2 of the 1 meter 600 beams. Okay, all good with it. I'm glad some people are showing me a thumbs up, and I can see that that there's an understanding of what goes on here. Okay, so we have that. But when we look at this, when I look at my drawing there, I can see that what it is that I've measured now is an overmeasure. It's an overmeasure because I now need to, at that section there, section there will not have any concrete. Guys, can we just pause there? The cardiologist that is phoning me. I'll just need to pause quickly. My apologies, guys. No sweat, nothing to stress about. I'm sorry I'm interrupting this class so much there. Where was I? Okay. That section there will not have concrete. Maybe I should draw it. That will not have any concrete in. It means that what I have colored in there is overmeasured and that needs to be deducted. All with me? It just makes sense that it cannot be a solid 300 slab as it is. And we said that we're using this to use less concrete and to also reduce some of the weight of my slab. So when I go in and I deduct, I now deduct reinforced concrete 30 MPa 19mm stone in composite hollow block slab with prefabricated beams, including beams and inverted beams. And I'm going to look at, and we're going to now determine the dimensions of each and everything. But before I do that, I want for us to again have a look at where the slab sits, or where these beams, these prefabricated beams sit. And you see that they sit halfway, at least halfway into my beams. All of them. All 1, 2, 3, 4, 5, 6 of them. All 6 of them, they sit about halfway into that beam. And my blocks, and we will now look at how determine how we arrive at whatever dimensions are that they speak of. I will first of all deduct the blocks. Now we look at the shape of those blocks. What shapes do you see for those blocks? The shape of the blocks, I hope that this helps that you can see what it is that I'm writing and trying to show. What shape do you see there at the top? What shape is that? A trapezium, right? And what does it mean? When I need to determine the area of a trapezium, what do? I say that plus that. I say the top plus the bottom, and then divided by 2. Okay? All agree with me? Because I need to deduct something. And at the bottom there, I have a rectangle. So, what I need to do here, I've got 180, so I have 180 plus 260, and that divided by 2. And I will then have the mean width across there, and that mean, or the average width across there, would therefore be, it's 440, so that is 220. Is that correct? 220, and that I will then multiply by the length and multiply by my height of 160. For my rectangle, it will be 180 multiplied by the 40 multiplied by my length. So that's what I need to deduct. I need to deduct, and let's go and see where that goes in. So I need to deduct for my blocks. We say that it's 1.6. Across that 1.6 I get from there. 1.6 I have is given to me over there. 1.6 is given over there, and that gives me the length of the blocks that I need to deduct. So it is the 1.6 multiplied by 0.22, which is the mean that I've already determined. And there is that mean over there. That is the half of 180 plus 260 gives me 220. So it's the 1.6 times 0.22 times 0.16, which is the height. And then we multiply that by the number of blocks that we see there. 1, 2, 3, 4, 5 of them. It will be 5 that we see. You can see the blocks over there. It is 1, 2, 3, 4, 5. That is the 5 of them that we have in our total. And whilst we're looking at that, I'm not going to look at the deduction of the beam. I'm not done measuring the block. But I'm just going to show the beam. It will be 1, 2, 3, 4, 5, 6. All understand Roman numerical. So that is there. But just so you can for future for where we're going to now. So when I now go and I look at my reduction, I've got my blocks. I still have 1.6 by 0.15 by 0.04. It's a 40 millimeter thick of the bottom part of the block times 5. And then now for the beams, how do I get to the beams? We said that the beams that we're looking at calculating the beams going just about halfway into my beam, my perimeter beam. So it will be the 1 meter 600, and I plus 2 times 100. Plus 2 times 100, that is twice into the half of the beam, because the beam is 200, so half of 200 gives me 100 on either side, and that gives me a length of 1 meter 800. 1 meter 800. That's 1 meter 800 times the 0.14 times 15 times 0.04 times the 6 that we've ascertained there. Okay. Also good. Then look at the formwork, and this is what I discussed earlier when we said when I started analyzing my drawing and what I do as to where the solid sections would be, where we would have to deduct. Now, my formwork, I need to formwork to sides and soffits of my beams, including propping up, exceeding 1.5, not exceeding 3.5 meters high. Where do I get that from? I look at my height. My height is given to me as 2250 to the underside of the beam. Right? To the underside of the slab, it is 200. So that tells me it falls in the category of exceeding 1.5, not exceeding 3.5 as per the standard system. I need to measure, and when I do measure my formwork, I have to my beams on along the perimeter there, that would be 2 times 3 meters times 0.6. Where do I get the 0.6 from? The 0.6 I get from sides and soffits of beams. Say, That's a 200 plus a 200 plus a 200. That gives me 600 girth. When I look at my length, I say that it is a 3 meter times 0.6 times 2. That is for my opposite sides. And then I have 1.6, 5.6 times 2. And then, yes, it's reflected as an edge to the edge of the slab, but in actual fact is to sides and soffits of beams. And if I draw this beam, we are speaking of, if that is the top of my slab, I'm talking of that section there, which is, what is the size of that? It is then reflected as 300 millimeters high. But the standard system still tells me that if it does not exceed 300 millimeters high, or thick or wide, it is therefore measured in meters. Now 300 does not exceed 300 millimeters. But 300 is on the dot there. So we will measure that, but this is not part of edge of slab. It actually forms part of the sides and soffits of beams. That is why it is measured in meters squared. And it's my 3 meter on the outside multiply 0.3 times 2, and by 2 meter on the outside multiply 0.3 times 2. And that comes, and that is on the outside there. That is where that is reflected. The section that says it's edge of slab. Actually is sides and soffits of beams. Okay. All with me?
Yeah, more.
I don't see any hands. We will move on. We will now look at formwork to the soffits of the adjacent flush surfaces of the hollow block slabs exceeding 250 or not exceeding 500 millimeters thick. Composite hollow block slabs including propping up exceeding 1.5 not exceeding 3.5 meters high. What does that mean? It means very straightforward. When I have a look at my slab here, at the section of the slab, it speaks to, as I said earlier, we do have the section where there is no hollow block. And we know, and we can see over there, that is as a thickness of 300. And the standard system tells me that formwork to soffits of slabs are measured to not exceeding 250, exceeding 250, not exceeding 500. The reason for that is it becomes a lot more costly and our supports will have to be a lot closer to one another the thicker the slab goes. So we're measuring for this section there, for the formwork to that solid section there, we're measuring that, and in measuring that, we can in actual fact determine what the dimensions for that would be. And we take the inner dimensions of 2 meters 600. I want to show. We take the dimension of 2 meters 600. And we have 6 by 150. Right? We have 6 by Guys, have I been muted the whole time here? Did you not hear anything that I've said here now? Have I been muted the whole time?
Yes, sir.
Yes, sir.
And nobody says anything, and you can see me writing and all of that. No, don't believe this. Today's not my day. So, where was the last that you guys were with me? Can somebody tell me where the last was that you heard me?
When you were explaining the 3 meter by 0.3.
When I was explaining which one? Nomta?
The 3 meter by 0.3, I think it's formwork.
So the last time you were with me was when I spoke of that section there. Where I said it was the 3 meter times 300. Is that the last one?
Yes, sir.
So that was when I spoke of the sides and soffits for beams. Oh my word! I cannot believe that I did not unmute my mic, and I expected you guys to speak up and tell me. You could see me writing. You could see the screen moving, but you did not think of telling me that I'm muted.
Sir, I just thought that the video was lagging.
You just thought the video was lagging. No, please, guys, next time interrupt me and tell me, because now I've said so many things that I think I've forgotten what it is that I've said. So we spoke of. Was it that one there? Is that
No, past that.
A bigger?
Past that.
No, it cannot be past that.
No, it's that. Sorry, sir. It is the formwork. 2 sides of soffits. Yes.
2 sides of soffits of beams.
Yes, sir.
Okay. Where I had that. And I said that
Yes.
day was 300. That one.
Yes, sir.
And that's where I arrived at that. And I also showed that it is made up of that, and that is where my 2 by 300 goes there, and the 2 by 300 and the 3 by 300. That's it. Okay. But you do understand the gist of what it is that I've measured there, measuring the sides and soffits of beams, and including that in the overall dimension, and that is that over there. Okay? So you've got that. Okay. So when I look at, and I'm going to go back to this one now again, when I look at the formwork to the soffit of the adjacent flush surfaces of the hollow block slabs, exceeding 250 and not exceeding 500 millimeter thick composite hollow block slab, including the propping up and exceeding 1.5 not exceeding 3.5 meters high. That refers to, and as the standard system says, any slab that exceeds 250 but not exceeding 500, we measure them in those separate sections or categories now. The reason for that is that we will now have to increase the number of supports because my slab gets thicker, and when it gets thicker, it means it gets heavier. So we have to now measure them in those respective categories, and we also need to determine how we arrive at them. And when I look at, and I'm going to get back to that, where I was to my drawing, to show where that takes effect of. It takes effect over here, and that description that we have there speaks of those two sections that I've colored in there. And in order for me to do that, I now need to stake my dimension on the inside, which is there, and that gives me 2 meters 600. And I see that I have 6 of 150, that will be the beams, and I have 5 times 180. And I would then add those to one another, and I'd say 2 meters 600 minus those two. Let's say that 2 meters 600 minus those two to determine what that length there would be on either side. Right. So looking at my dimensions now, I can now say that it is my 2 meters 600 that is shown to me. My 2 meters 600 minus the 6 by 150 minus the 5 by 180 for my blocks, and my dimension there, therefore, is the 800 in total, and divided by 2 gives me 400, and that's 1 meter 600 multiplied by 0.4 times 2. That is for the solid section on either side of my rib and block slab. I also have here my type of blocks. Now, we normally get given the types of blocks that we will be using, and the different types of blocks are given with their respective numbers dependent on the depth of the blocks, dependent on the thickness of the blocks. And all of those would determine what the type is. And this is now just given a general type ABC, hollow blocks in composite slab size 180 at the top, 260 at the bottom, 200 millimeter long, that is each block 200 millimeter long, and 200 millimeter high, laid in position. So what that refers to is, as we can see, yes, there it is on section. There we have a hollow block detail that shows the 180 at the top. It shows the 260 at the bottom, and it shows the 200 in height. Right? Now that does not show the width, but the width we will get based on the type, and the type will normally get that from the block manufacturers, and whereby we would say, but we could go in and we can see over here, we can see clearly over here where all these blocks are shown and how they would be placed across there. So when we measure, and we know that the block sits in between, and the blocks with length of that would be 1 meter 600. So the type of blocks, effectively saying they are 200 millimeters long. We can therefore go in and we can see over here that it tells us that the length of where my blocks would go in, the 1 meter 600, divided by 200, because 200 is given to us as part of the specification, and it means that we would have 8 blocks per row. And we have 5 rows, and that is 5 times 8. Okay? The same with my precast or my prefabricated beams. So it's type XYZ. It's just given to XYZ. It's not type XYZ. Different manufacturers have different codes that they call these. And we will generally, as QSs, we will communicate with these manufacturers and say, what do you call these? What do you call them? What's your type? What is all of those? And we will use the information that they give us in order to draw that up. And we'll say prefabricated block beams in composite slab size 150 by 40. I've shown previously where we get those dimensions from. The 150 was given to us, and the 40 I indicated that the 40 we get at the bottom of the block, where the block has a lip, and that is where the block will sit on the beam. And that is 150 by 40 millimeters high, with 2 10 millimeter high tensile reinforced bars in lengths not exceeding 5 meters. Now, where did I get that 2 10 millimeter high tensile reinforced bars from? It's also given to us on the drawing. It tells us it's prefabricated block beams with 2 by Y10 rods in them, not exceeding 5 meters. What's the length? We've already determined the length of my block, of my beam, my apologies. And we know that we also determined that there are 6 of them. So it will be 6 times 1.8. Then move further and I say 76 by 114 SSAP bearers supporting soffit of the composite slab, hollow block slab, propped up exceeding 1.5, not exceeding 3.5 meters high. What on earth is that? Where on earth are you talking about, sir? Talking about 76 by 114 timber bearers. What is a bearer? A bearer is something that supports or carries a structure on top. It's like when we do a floor slab, a timber floor slab, we have bearers that carry the joists, that carry the flooring boards. In this instance, we have bearers that will carry, and we will need to determine what that length is. And where are we talking about? I'm going to show, I think it's best if I show it over here. Okay. The bearers that we're speaking of, guys, would be in support the bearers over there that will be supporting the slab, especially over there. Bearers will be supporting there to prevent that from sagging. Okay? So I need to determine what these lengths are. What are the lengths of what there is? So what do? Remember that in quantity surveying we measure net. We measure net. We do not allow for waste. We do not allow for lapse. We don't allow for that. We measure net. So we will measure, you say it is 6 by 150 ribs. And we add 5 by 180 blocks. And that gives us a length of 1 meter 800. Even though when it gets placed, it will be placed if that is the solid sections, even though it will be placed beyond, and there I will have, even though it's placed beyond, we are not concerned with that because we measure the net area. We measure the net length. And that is what we calculate by saying 6 by 150 plus 6 by 180 in order to ascertain that there. All with me? All with me? Right, I know we all are with me because this is very straightforward. It's not difficult at all. And then you say reinforcement to take. What does to take mean again?
Next time. We'll check next time.
I've forgotten what to take stands for. Somebody please remind me. Nobody knows what to take stand for. To take means that we will be measuring the reinforcement at a later stage. We'll be measuring the reinforcement again. Okay, that is drawing 16. Ribbon block slab, very straightforward. I'm now ready to field questions before I move on to drawing number 17. No questions? Fine, can I proceed? Yeah. So silence means yes, thank you very much.
Sorry, sir.
Yo.
Can you go back to the bearers?
To the?
Bearers.
The bearers.
How did you get the number of bearers?
The number of bearers?
Yeah.
The number of bearers, we looked at the width there of Odwa, and we normally place what we normally place our bearers at. We normally place our bearers at what 500 centers, and it was purely based on how we see it and placing the bearers at those centers so that we can ensure that we would not be falling foul of it sagging, but we generally would look at about 500-600 centers and measuring them and taking it from there. Which in most instances it is really not a trench match, but for the bearers, what we would do is we generally would go to look at about 500-600 centers and take it from there to ensure that we have equal spacings. You can of course go more, but not less. But not less. But you can work with about around 600 centers. You work with 600 centers. You get 2 and 2/3 spaces. So working with that, you should be safe. But even if you work at 500 centers, you work with 500 centers. 3 spaces means 4 spaces, and then you have your three bearers that are in there. But as I say, when you're dealing with that, you can say 500 to 600 spaces. I trust that answers your question, Odwa.
Yes, it does. Thank you, sir.
Okay.
Yeah, you're not.
Right. Any other questions? Nothing. Okay. I'm going to look at the next drawing. So the next drawing is exactly the same size as the one that we've just done. It's the exact same size of the one that we've just done, but of course there is a difference to it. There's a difference in the sense that when we look at the drawing, we notice that instead of ribs and blocks, we're now sitting with trough. And if you're going to have a look at, if those of us who know what a trough slab is, who knows what a trough is, those of us who come from the farm that knows a trough is basically where we would use, if we have cows or any fodder, then we would place the feeding in a trough for them to feed out. The same principle is applied here. This trough is one section that almost looks like a bath. A bath that is turned upside down and forms the formwork to the slab of mine. And if we look at this here, if you look at the section, this trough there, we should just come out there. You can see there the shape of that trough. It's like an upside down bath.
Yeah.
And those are solid sections. These here would be hollow. Those would be hollow, and we'd have the solid concrete. That will be the solid concrete. So when we go and we have a look at over there, this is where this ends, and this is where this is where this trough, in that same shape that I've just seen on the section, that is where that trough would be. And that trough would have like the shape of a partial non-square
Rectangular.
A partial. What's the term I'm looking for? Not for a what's that shape? Prismoidal, not a prismoidal shape. I cannot think of the shape now. I feel, but it'll be like not like a pyramid, but it's like a partial pyramid, but a non-square partial pyramid, and that is the shape that we would have here. So when we look at this, that is what we have. Again, our solid sections on the perimeter of that, and when we measure this, slightly different, but we start off with the same principle. So we measure that and say the reinforced concrete 30 MPa 90mm stone in trough slabs, including beams and inverted beams. So we measure our dimensions overall. Our thickness is still the same, the 300. So it's 3 meter by 2 meter, 5.3. So the slab for the beams will go to do the same that we've done for the beams in the ribbon block slab. Exactly the same, the 3 meter by 0.2 by 0.2 and the 1.6 by 0.2 by 0.2, and both of those multiplied by 2 as we have the 4 sides, 2 shorter sides and 2 longer sides. And then we deduct the concrete 30 MPa 19mm stone in the trough slabs, including beams and inverted beams. And looking at the troughs, we determine, and I see now on my drawing, I know that my dimension from there to there is the 1 meter 600. I know that my dimension is there 1 meter 600. But I also notice that I have 100 millimeter on either side of my trough. Meaning that it is 1 meter 600 minus 2 by 100 gives me a length of 1 meter 400. Right? I've got the height of my trough, is given as 180. The width of my trough at the top is given to me as 280 and the bottom as 340. All dimension sizes that I have to take into account when are determining what I need to deduct. When I take that into account, and I'll say and I have a look at 280 plus 340, and I get half of that. Because 280 plus 340 gives me 620, and half of that gives me 310. So the 310 where I have that gives me my 310. The width across there. 310. That 310 is there. The 1 meter 400, I've already ascertained the length of 1 meter 400, and I know that that is the overall length of my trough, and my height is 180, and how many of them are there? I have 4 of those. That's what I deduct. I move further, and I look at the formula to the sides and soffits of my beams, and I'll use the same principle that I've measured for my ribbon block slabs. It's the exact same dimensions that I've gone through. I've explained that in the previous. I'm not going to explain that here again. For the beams and the sides and soffits of the beams to the edge of the slab. We've done that. So we now look at the formwork to the soffits, the formwork to the bottom of this trough slab. To be formwork to the soffits of the trough slab exceeding 250, not exceeding 500 millimeter thick, with 100 millimeter wide ribs. Where do I get that? As shown to me on the drawing. Shown to me on the drawing there that my ribs are 100 millimeter wide. So my ribs would sit there. What ribs? Are they prefabricated ribs? No, they're not prefabricated ribs. What ribs are they referring to? It is the beam or the rib that is being formed by the formwork, to these troughs. It now creates that beam, because we now have a beam that is formed there. We have a beam that is formed there, and that gives strength to my slab. So you're now saying that the formwork to my beams at 100 millimeter wide ribs at 440 millimeter centers, including propping up, exceeding 1.5, not exceeding 3.5 meters high. Now, where do we get those centers from? Those centers would be given to us by the engineer. The engineer would tell us that the centers of these would be at that But also, you also get that from my drawing. From the drawing, that also shows my trough. Now, how do I get that? From my trough. Because the beam of 100 millimeter that is formed there indicates that we will then have to at least have something in between there. And if I look at my beam of look at my trough of 340 millimeters. I look at my trough of 340 millimeters. That 340 millimeters would be to there, right? So we add the 50 on either side, and that is how that is made up. At being at 440 centers, because the 340 plus 50 gives me 390 plus the 50 on the other side of the trough gives me 440. And that will be the centers, or that I would be placing these at the 440 centers that is indicated to me over there. I hope you understand what it is that I've just said now. Also given to us the 440 centers. It is the 340, which is the beam size, or the trough size, the 340, plus 2 times half times 100. The 2 times half times 100, if I can draw the trough, that is 340. So we're going halfway into my 100 on the other side. So that will be 50, and that will be 50. It means that they are overall at 440 centers. Brother, you've got the length of them, 1 meter 400, and we now need to determine exactly how much and how far it is that we need to measure with this. We have the 1 meter 400 of the formwork overall, and we need to now determine, we see that we have 4 of these troughs at 340, plus in between we have 3 beams of 100 millimeter wide. So we have, it will be 4 times the 340, which is the 4 troughs, plus 3 times the 100 is, and that gives me 1660. And what does that refer to? Where does that refer to? What is the formwork that we're speaking of? The formwork that we are referring to in this instance would now be, ladies and gentlemen, would be there. That's the formwork that is being referred to in that description that we've just spoken of. Because in that, we are telling that the support should be for these troughs, to hold these troughs up, saying that the beams that are there are at 440 centers, the beam widths are 100 millimeters wide, and it will support a trough of 280 by 340. Right? That is for that section only. We've now not measured the section, the solid section outside of the trough area. That comes up next. For the full area, we measure the full area, which we know is 2 meter 600 on the inside of my beams, 2 meter 600 by 1.6. And we say, formwork to the soffits of the adjacent flush surfaces of the trough slab exceeding 250, not exceeding 500 millimeters thick, including propping up exceeding 1.5, not exceeding 3.5 meters high. Now, we're taking an easier route here. We can of course go we can go and measure the sections individually, but it's easier for us. We've already measured the troughed area. So we take the overall area and we deduct the troughed area which we've already measured. And that gives us the area of where my solid concrete would be placed. And I've got formwork to the top and the sides of the trough, 280 millimeters wide at the top, 340 wide at the bottom, and 180 millimeters high. Now, what on earth does that talk about? Formwork to the top and the sides of the trough, 280 millimeters wide at the top, 340 millimeters wide at the bottom, and 180 millimeters high. What do you think we're talking about there? Formwork to the top and the sides of the trough. Anybody? Anybody want to try and think what it is that we are talking about here? No one. I also don't know. Nobody wants to take a chance on what it is that we're talking about. What I'm going to do, I'm going to go back and quickly take us to the standard system.
Sir, I can't hear you.
No. I'm in the standard system. Can you see the standard system?
Yes, sir.
No, I'm searching. I'm searching. Thank you for that. Thank you for that. I'm searching here for the section that speaks to formwork to troughs and that. Okay, if you have a look over here. It tells us that additional formwork says formwork to troughs of composite prefabricated beams and trough slabs are measured in meter. Right? That's additional. The troughs of composite slabs. So this is what it is that we are now looking at measuring here. When I just get back into okay, our description says formwork to the top and the sides of the troughs, 280 millimeter wide at the top, 340 millimeter wide at the bottom, and 180 millimeters long. Now it says because the standard system tells us that troughs are measured in meters, and we now know that the length of this here, at the length of that has been given to us as That's 1 meter 400. And the standard system tells us that it's measured in meters. All that we're doing, we are describing the size of this. We're describing the size of that, and we know that the shape is that, and we know that the shape tells us it is 280 by 340 by 180, and we're giving the size of it, and we're measuring times 1, 2, 3, 4. That's all that we are doing. We're saying that formwork to that, and that those troughs are then how the contractor prepares them. We are not concerned. So what we're doing, we're saying that that is the size 280 by 340 by 180 high, and there's 4 of them at 1 meter 400 long. That is how we would measure the formwork to that. Slightly easier than measuring ribbon block. And again, our reinforcement would be 2 take. Okay, we've got a couple of moments left for some questions. Some questions towards for trough slabs and that? Anybody? No questions. Are we all happy? This is not too difficult. I don't see any hands. Nomta, you happy? Great stuff. Ottawa is happy. Yeah. Right. Guys, I just need to know and understand. I told you guys I've got this new tool. I'm still learning how to work with it. Did it help me writing on the screen? Could you see what it was that I was writing to illustrate? And it took a little less time than trying to navigate with the mouse and trying to show what it is that I'm talking about. Did that help? Okay. No, great stuff, guys. I'm glad. As I said, I'm gonna try and do YouTube videos too. How successful I will be with that, I don't know. But this is the route that we will be going. I'm actually sitting here with a tablet here one side, and I have 2 other screens trying to get through everything. But it's trying to this fine tuning and getting it all in the right space that is very important. But I'm glad that it helps some. And if there are no further questions, there's one question that I know that is, I'm just about done marking. I know it takes forever. It's like pulling hen's teeth on my side. I'm just about through marking. And pretty shortly, the marks will be uploaded on the system. Right? If there aren't any other questions. And I'll try and do my uploads earlier, as I said. Just know that we are extremely busy. I'm busy with shortlisting for positions that are that in itself is a mammoth task. But I'd like to thank you for your patience today and for being here today. And I trust that we've learned something that I've managed to transfer some knowledge over today. Have an awesome day, and I will have a look into Sandile and Noloiso. I'll look into your issues so that I can ensure that you have got access to everything. Okay, guys, have an awesome day further. Stay safe and keep your social distancing, even from your girlfriend or boyfriend. Right. Okay, guys, have an awesome day, and we'll chat again. Stop the recording.
Oh, right. Okay.